I hear you, Yoshi.
Any system that generates data needs a way to persist that data. Broadly speaking, we call that a database. But with so many databases, it might be hard to achieve consensus on the perfect definition. This is Data Skeptic Consensus, and the 9th installment in our series about how multi-agent systems achieve collective decision-making. This week, Linhda returns in the format of our mini-episodes from yesteryears. We're going to discuss ACID compliance, 4 related and very important properties a database can offer you if you need pretty strict stuff. We get into some examples, including, oddly enough, Rummikub. So all that and more in just a little bit. Welcome back to the show, Linhda.
Welcome, Kyle.
So I wanted to talk to you today about a topic called ACID compliance, but that's a fair amount of jargon, so I thought we'd warm up with some real-world use cases. We've been having, intermittent Wi-Fi issues. I don't know if you want to call out this villainous provider we have, but specifically, I imagine you're on Slack at least sometimes when the Wi-Fi goes out. Can you describe your experience? How does Slack work that out?
I haven't noticed much interruption. I mean, Slack still lets me do things, but they add a little banner that says some kind of connectivity issue, so I can still access the existing Slacks that I've received. And then I believe when it reconnects, I'm able to send the message.
And sometimes you get that little thing that says message stuck pending or something like that?
Yeah, maybe. I don't remember. It does have a gray message.
Right. So Slack's in a difficult position from a software perspective. They would like to just say internet is required, but of course that's not totally realistic and they don't want to annoy the user. So, obviously you can't search deep into the archives of a channel, but if your local copy is there and you can search a little bit back, it's going to hopefully do that for you. So it seems like they engineered it pretty good. Maybe I could make some suggestions, but overall, pretty good experience there. Similarly, have you ever noticed issues where SMS comes in the wrong order or stuff like that?
Oh yeah, it's so annoying. We have T-Mobile, so sometimes it happens and I don't know what causes it.
Well, some engineer somewhere knows. Maybe he or she can write to me. I don't know anything about T-Mobile specifically, or it even might not be them. It might just be the system or the network or the other network you're communicating with or stuff like that. Couple more here. All right, so Google Sheets. Have you ever been editing a Google Sheet at the same time as somebody else and they start to edit a cell? What happens?
Well, I should see you make your changes live. That's what I've experienced.
And it locks you out of that cell, right?
I don't know. I've never tested the same cell. Is that what happens?
To my recollection, and of course they could be evolving their approach to this, if I start typing a cell, you will see it locked. In other words, you can't edit it, and also grayed out where you can't see what I'm entering. I could see maybe them enhancing that, and perhaps they have since last time I checked even, where you could see a preview of what I type, but you wouldn't be able to edit the cell while I'm editing it. It's sort of like a library book, right? One checkout at a time.
Right, that makes sense because that would probably be confusing.
Yeah. All right. Now, my last one's a bit of a stretch, but this is really going to capture the idea of a database transaction. Do you know the game Rummikub?
Oh, yes. We have played that several times, and if I do recall, I win.
I'm going to dispute that part, but we haven't played it in a while, so I'm not expecting you to know the official rules. But broadly speaking, how does the game work for listeners that don't know?
So there's tiles, and the tiles have different numbers that are colored on them, like red, black, blue, yellow, and you kind of put them in a set. I think to make a set, you have to have at least, can't remember if it's 3 or 4, but you put them down and then just lay them out, and you start laying them down on the table to get rid of your tiles.
And then you can start doing combos, right? Like if you're doing a group of 3s and there's some 3s on the table, you can pull them out of another group and add them to your group, as long as the group that you took them from still remains valid.
Right, it can't go less than 3. And you can join up groups too.
Yeah, so this is not too dissimilar from a bank, right? A bank, if there's a transaction, I'm going to send you some money or something like that. They first want to check that my balance is not 0. And then if I take out those funds, that it doesn't go below 0. And then they want to make sure that your account is still open, and then that your business confirms that they accept or your bank confirms they accept the transfer. So there's a lot of like micro steps in there that the average person doesn't think about. And if any of those go wrong, the jig is up. You call the whole thing off, right?
But when you say call the whole thing off, do you mean the transfer doesn't go through?
The transaction, yeah. So let's stick with Rummikub for one more minute before we do banking. If you got yourself into a complex Rummikub situation where you were stealing from different groups and trying to make a bunch of new groups, you have to leave the board in a valid state. You can't just kind of be like, I didn't really make it work. If anything, you have to do a whole bunch of Control Z and undo yourself. But in theory, you could make this complicated combo where a bunch of stuff changes all in like one coordinated effort, right?
Yeah, you could do a lot of things at once.
But you can only finish your turn if the ending game board is valid.
Yes.
And even in between, it could kind of be sort of invalid. Like you could say, all right, I'm stealing some rummy cards or whatever from one group. Maybe the group size could go down to 2 temporarily because you are going to fill it back up. You're just moving stuff all around. So the game board becomes like temporarily invalid until you finish it. And you have to finish it in a valid state. And if you can't do that, it's got to roll back to the very beginning.
Right, that's true. It's just like any board game, right? Because on any board game, only one person can do a move at the same time.
Yeah. Now, that gets us to our next point. There's only one turn going on at the same time. And in Rummikub, that's okay, right? We're all there together. We're having fun. We're not trying to rush through it. We each take our turn. But I don't want to wait at the bank. I don't want to stand there all day because your transaction's slow. But you do need to be able to like lock things up to do a transaction. A bank has to maintain that same policy. One person has a turn at a time, so they have to make the turns go really fast. And that's one of the services a database does. So in a database, you begin a transaction, and that's literally how you do it. You type a begin transaction, and then you execute a bunch of SQL commands. And at the end of it, as long as the database is valid, you say commit transaction, and then all of those changes happen all at once. Or you could say roll back transaction, in which case you go back to the previous state where you started from. And in either case, when you're done, whether you commit or roll back, you now unlock all the parts of the database you were using. You say, hey, I don't need these exclusive anymore. Other people can use these things, or in Rummikub can use those groups on their turns. Make sense?
Yeah, I could see that. You're saying the changes happen all at once. So if I were to put a sound to it, it'd be like vit, 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 vit.
I like that. We should trademark that and sell it to a database company because we just got to the A in ACID compliance, which stands for atomicity, that all of those things happen all at once. You know, if we're going to do some complicated transfer from here to there, it doesn't happen incrementally, that the database service can provide you this ability to make a bunch of changes all at once or none at all. ACID, if I didn't mention it, was an acronym or probably a backronym. So we did A. C, any guesses?
Cat. C for cat.
Thanks to this week's sponsor, Brilliant. Brilliant's a longtime sponsor of the show, and I hope by now you've all checked out their awesome platform. It's a great learning tool. They've got these really excellent courses and learning paths, and even the problem of the day that can help keep you sharp. I do spend a little time on Brilliant every week, and lately I've been going through, I announced this a couple, months ago when I just saw this was in preview. Out now, the quantum computing course. I'm very excited to dig into that and report back later on how I'm doing. 33 interactive quizzes, 395 plus concepts. Learn to build quantum algorithms from the ground up with a quantum computer simulated in your browser. And I saw some of the demos for this. It is a fun, interactive thing, just like all the courses on Brilliant. If you're interested in quantum computing, you definitely need to go check that out. There's a fun way they're building quantum circuits. But if that's not your cup of tea, perhaps Introduction to Neural Networks or the Logic course are for you. There's something for everybody and maybe even for the whole family over at Brilliant. So head over to brilliant.org/dataskeptic. That code will get you 20% off a year of Brilliant Premium, so head over to brilliant.org/dataskeptic. Normally a good guess, not what they meant in this case. Consistent is what they were going for. And I've kind of harped on this a little bit too. Basically, consistent in the vernacular means it's never invalid. So even if, like in the bank example, maybe a bunch of money's moving around in a bunch of accounts during one transaction, hypothetically, one of the accounts could be negative during the transaction, but all accounts have to end with a positive balance.
Okay.
So that's another very desirable property. What do I got next? I, for isolated. That one's a little weird. It means even if you're doing things concurrently, they still occur as if they were in a sequence. Does that make sense?
So even if it happens at the same time, you still got to prioritize it.
Yeah, and here maybe I should roll back what I said about the account could temporarily go negative. Obviously, banks have all kinds of crazy rules, and they will let you go negative because then they can slap a nice fee on you. But in theory, so when it happens in isolation, that's part of that transaction. That if I check a balance and I'm like, okay, the balance is good, this person can afford to write this check. By the time I say approved 3 or 4 lines of code later, it cannot be that since then the banking balance changed.
Right, because yours takes priority.
You got it. Otherwise, we could pull a scam, right? Where if you and I could coordinate really well and use our same ATM card from our shared account at the same, 2 different places at the same exact time, maybe we could both clear out the last bit of the balance if we were really fast and sneaky. Isolation says no.
Right, so that's what we were talking about, what happens in the old Western movies, because back then the banks didn't have this right. So you could do fraudulent withdrawals at the same time.
Hey, that's a very good point, yeah, because there was no good way for those banks to communicate. So I assume, this may come as a surprise, Western economic banking initiatives were not covered in my computer science training, but I would suspect they had some sort of put a hold on it kind of a thing, where you send a messenger to confirm with the bank that the balance is there. Although that opens up a whole series of other problems, like how do you acknowledge that you got the acknowledgement kind of stuff. But we'll leave that for another day. You're right, the Western bank highlights why isolation's important. Last but not least, the D of ACID is for durability. That is to say, once you commit, your changes are committed. So if I say, hey, we've just done this big complicated bank transfer amongst 8 different accounts, all the validation passes, we're happy with the changes we requested here, please commit them, that if the bank says, yes, that was committed, that it was in fact committed, which sounds rather obvious, right?
Yeah, but with technology, you just can't be more clear. You just got it to commit, make sure it commits. One wrong move, then all the other subsequent ones are wrong.
You're right, although it goes a little deeper even than that. Durability is the property that feels obvious, like of course it should have this. If you said you committed it, you need to have done that. And that works great if you have a single system, like one monolith database that doesn't have the server never goes down, anything like that. Basically an unrealistic scenario. Every server, if you just have one, there's a limit to how that can scale. So you might want to get into a fleet of distributed computers. That opens up a separate problem called the CAP theorem that you and I have talked about years ago, and we're going to talk about in some upcoming episodes. But for the moment, let's talk about databases that just have one and only one server. So there's no CAP theorem, there's no distributed stuff, and it needs to be ACID compliant. Well, those database servers, in order to be fast and efficient, they do smart things with caching. So like hold something in memory. Here's something you could do. In order to let the user know quickly that their transaction was approved, as soon as in memory you have it worked out, you say, okay, you're approved, and then you end the connection. And then afterwards, asynchronously, you would save that record from memory to disk. And that kind of happens in a lot of like word processing documents. You'll be typing for a while. Your changes are temporary, right? They're not saved. But most software today auto-saves it every so often. That autosave wasn't always a feature, and it's not an easy guarantee to make. So it could very well be that a server of some kind, some database says, yes, I got your transaction, everything's good, I acknowledge it. But then in the time between they acknowledge it and when they finally write it to disk, which is the ultimate backup, the power goes out. Now what? They've lost it.
So you're talking about a real world example.
I am indeed. And when you do millions of transactions, anything at scale, you're going to see these problems. There's going to be a day when the power goes out and all that kind of stuff, or a hard drive fails or memory fails. So many, many challenges to database design. And broadly speaking, smart engineers in the past have figured out ways to deliver this service. But ACID, the acronym you should know when you talk about databases, does it do this? Atomicity, consistency, isolation, and durability. If it does, that's, sort of the highest standard of database accuracy and whatever. These are very nice properties, although not always required. If you're Facebook and you're going to display how many people have liked this page, I don't think you need to be as concerned with, at the exact millisecond the person refreshed the page, you get precisely the number of likes. It's not the stock market. You can be fast and loose. So you relax some of these constraints, and then you don't need such a fancy piece of technology to solve your problem.
So wait, why would one relax these constraints?
In a situation like that, like Facebook wants to say, however many people have liked this page. If they're off by 1 or 2, because like there's some delay or whatever, it really doesn't matter. Just refresh the page to see the new number. That's very different than a bank balance where like, I don't want to see like, oh, the check I just deposited, did it disappear? No, it needs to always be there. It's a different level of standards you need. So banking in my mind is always like the most strict, showing like, oh, how many people have liked this page. I'll relax some of those constraints. It doesn't necessarily need to be super durable or atomic or consistent.
Okay, so you're not valuing accuracy or precision. So then that's why they would do it. They'd be like, it's just the good to know. No one's risking their life on this.
Yeah, and just to be clear, it's not that the number is going to be wrong. Like I'm like, oh, Facebook is just publishing nonsense data about likes. It's probably so close that the number of people who see errors is like, 1 in 10,000 people see it off by a very small amount. And that's okay, but not in banking.
Actually, it's funny you brought up banking. Banking actually creates additional states. Like when you deposit a check, it won't reflect the amount, but they have a state where it says processing.
Thanks to this week's sponsor, Monday.com. We're getting the word out this week about the Monday Apps Challenge. How many of you have ever dreamt of building an app that impacts the daily lives of hundreds of thousands of people? See, that's what's so interesting to me about this opportunity. You build an app, you put it in some random marketplace on iTunes or whatever, who knows if anyone's going to download that? If you participate in the Monday Apps Challenge and build something, not only can you win some fabulous prizes, but you have instant and immediate access to 100,000 teams that all use Monday.com for their daily work. And there's prizes too. Check out Monday.com/dataskeptic. There's $184,000 in total prizes. They're giving away 3 Teslas, 10 MacBooks, and a bunch more. So what does it mean to build one of these apps? All right, well, the Monday App Framework creates custom building blocks that are built by developers to extend the Monday.com Work OS. So here's some ideas. Build a really useful widget, or maybe use your data visualization skills to build some custom D3, pull some data from their Monday account and visualizes it for it. That could be a weekend project and could win you one of those great prizes. If you're interested in this, you ought to join the Monday.com Builders community. Stay tuned on announcements and get official help and stuff like that. If you're not on Monday.com already, your team should check it out. And if you want to check out the Monday Apps Challenge, learn more at monday.com/dataskeptic. That's a very good point, yeah. And so banks, obviously, I've maybe watered down some of their needs. Those states have been added to cover, different complex situations they want to track. So probably there's more detailed things there, like in terms of the state it's in. Once it's confirmed, it should never go back to pending, right? It's a one-way street on the status in some of the statuses. So there are other constraints like that actually you kind of get for free by having an ACID-compliant database, because you implement those in your logic somewhere, and then that logic can be part of a transaction if it's at the database level.
Right.
Now, when you think of databases and stuff, I suspect you have an image of them that they're kind of flawless. Meaning like they're not just going to suddenly lose data. Or am I writing too much for you? What would you say to that statement?
I mean, it just depends on my end, what I witness is whether the business agrees on those definitions of what these things mean. I don't know if the database is flawless or not. I don't really comment on that.
Yeah, you raise a good point. So in a lot of organizations, they may debate the accuracy of some report. Did it include this? Did you filter this way? All that kind of stuff. That's like internal business logic. I'm talking about someone says, we went into the Google sheet that has our P&L and all the values were different and no one had changed them. It was like a mysterious bug in the system.
Yeah, well, then I guess I agree with you there.
And for the most part, you can be confident that the data in the database is not going to be mutated, certainly if it's an ACID-compliant database. But pretty much every database has some sort of guarantees like that. If you don't need ACID compliance and you're looking for another technology that's maybe going to offer you some speed ups or some more robust things, you always have to look at how does it reflect both ACID compliance and then the CAP theorem. So like eventual consistency is one of the neat ideas that's come out. Consistency, remember, is the C in ACID. Yeah, if it has to be perfectly consistent, then that's strict. But what if you're like, just as long as it gets the right answer eventually, I'm good. That's very valid in lots of situations. So then you don't need ACID compliance. You can have eventual consistency.
Does eventual consistency have another acronym?
No, not directly, although it ties very closely into something called the CAP theorem, which I mentioned a couple times here. People can go back and listen to our previous episode on that, or like I said, some upcoming stuff, because this acid is just a prerequisite discussion, so I can mention this in some of the upcoming interviews, I think.
All right. So you heard that, folks.
Does it give you a greater appreciation for the efforts that go into the databases that serve you, or serve the technology that serves you?
No, but it just helps to know that there's an acronym, as in there's some kind of standard operating procedure, some baseline knowledge that people are passing on, and that makes me feel better. How does this relate to the theme about consensus?
So consensus in a database is where you have all of the nodes or all the parts of the database agreeing on a value. And that's in a distributed system, of course. ACID compliance, pretty much you have to have like a siloed, singular mono something. I'm at a loss for an exact word, but you got to have one server basically. Even though it might be multi-threaded, they're on the same machine, so there's smart ways to do that. When you have distributed systems, then there are real-world situations in which they might all observe different values. And so you need some way for them to agree, hey, what do we decide on? What is the final count of number of people who like this? Because I say it's 101, you say it's 102. Let's survey all the other people and take the average or something like that. That would be one approach. So you have consistency issues in distributed databases, not so much in singleton databases. And yeah, that's how it relates to our theme.
So it's more about consistency in interpreting the data.
Interpreting? No, it's not really interpretation. At the level of a database, your job is only to persist the data, to make sure that you can store it and respond to queries about it.
So consensus, what's your definition of consensus?
Oh, well, there are many. In this context, in databases, it's that when you have a fleet of machines constituting a cluster, a database cluster, that they have a mechanism by which they can all come to agreement on certain values. Not necessarily, how much percentage should we invest in R&D, not that sort of decision, but like if you have a bunch of sensors that all are measuring the temperature and they all give slightly different measurements, you need a mechanism to decide, all right, which one are we going to agree upon as a group?
Right. So it's more like alignment on what you guys are going to define as the number you will use.
Yeah. We have to agree that the variable T for temperature is 70 degrees. That, we've got 8 different measurements. There's some disagreement among them. There's a way we can arrive at consensus so that in the future, when people query the database and say, what is the current value, they get a consistent answer that everyone would agree with.
I understand. Makes sense.
So yeah, very Byzantine and all that. Anyway, that opens the road for discussions about NoSQL solutions and distributed solutions and stuff like that. So thanks, Linda, for helping me talk it through.
All right. Thank you. I definitely am not sure if I would hire you to set up a bank account database for me, but good to know you know the basics.
Yeah, that's not my exact specialty. I'll help you with forecasting and stuff like that. There are people that are highly specialized and they know the FIPS protocol and stuff like that. That's a whole other show. But yeah, thanks again for joining me, Linda.
Thank you.
That concludes this installment of Data Skeptic Consensus. Our theme song is Paradox by Odling. Claudia Armbruster is our associate producer. Vanessa Burciaga does guest coordination. Kyle Polich is the data skeptic. And Linda Tran appears as herself.